What's going on, creators and developers out there? My name is Erickson. In this quick VHDL tutorial video, we're going to be talking about latch. There are two things in this world you don't want to do. One is lie, and the other one is, you guessed it, infer latch unintentionally. So we're going to be quickly looking at how this is done using a simple practical implementation. We're going to be implementing this 3-input AND gate in the FPGA. So we're going to be using one of the input as enable and the other two as the two-ended input signal. And we're going to monitor the output on C. So if we go back to our VHDL code here that I've already put together for this demonstration, you can see you have your 4 ports, 3 inputs and 1 output. And here's your combinational logic that will generate the AND gate. So latches are inferred for a signal or for a variable. So in this demonstration, we're going to be looking at how latches are inferred for a signal. In later video, we're going to be looking at how they're inferred for variable. So latches are inferred for a signal if this happens. If a signal is assigned in a particular path, but not assigned in every possible path in a combinational logic, a latch will be inferred for that signal. So what do I mean by that? In this case, this signal is being assigned to the output of A and B and the output of A and B if enable is high. But if enable is some other value that is not high, this signal is not assigned, and the tool will infer latch because there is no assignment for this signal given other possibilities. So let's quickly run synthesis, and we're going to be looking at this from a schematic perspective, and I'll show you how latches look like and how bad they are in a particular design. So let's run synthesis. So synthesis successfully completed. Let's open synthesize design, and now let's look at the output schematic and see what we get. So let's maximize this window, and this is what we get. So, and I'll quickly explain what these blocks are. So this 3 input buffers are expected when designing with Xilinx FPGA. So you have your ports connected to a buffer, and your signal is routed to your internal logic. The same for your output signal. So there's an output buffer that takes your signal to the output pad of your design. And you also have this buff G in this case. It's not really important, but buff Gs are a global routing resource that takes your signal throughout the chip, and in this design we don't really care about. And you also have this block called LUT, which stands for lookup table, and lookup tables in FPGAs are used for implementing combinational logic, and in this case it's being used as AND gate. So you have your 2 inputs being ANDed together. In this case, you can draw an AND gate on top of this block for simplification, and you have the 2 output of buff G and this AND gate connected to this storage element. So this is where we get to this is the main block. This is what I want to talk about, because this is a storage element. Even though I don't imply any storage element in my design, the tool is inferring a storage element. So this is not a good thing. They're bad. Latches are bad in general for several reasons. They will create glitches. They will give the tool a hard time meeting time and even routing your resource. In a more complicated design, they will really create an unsafe design. So they should be avoided in every possible circumstance. So let's look at the code. Let's go back to our VHDL and figure out how to fix this, how to get rid of this unintentional storage element. Because the goal is just to have a 3 huge input AND gate for this design. So there are 2 ways you can fix this. I'll quickly show you one way, but they will all accomplish the same thing. So one way is to introduce an else statement. So else, and then ground the signal if enable is some other value. So what I just did is add an else statement saying, okay, if enable is 0 or some other value, ground this signal. So this is given This is assigning C signal for every possible path. Now let's save that and run synthesis and look at the schematic again. Right, so synthesis completed. Let's reopen synthesize design. And let's open the schematic again and look at this in golden. So latch or unintentional storage element gone from our implementation. So this is the goal, and make sure you really know how to eliminate latches or not infer latches in your VHDL design, because they're dangerous. Now let's go back to the code and I'll show you another way to get rid of latch. So this is one way, and the other way is to do this. Instead of providing an else statement, we could also provide a default assignment. So this is providing a default assignment for C signal if enabled is some other value. This is the same thing as having an else statement. So let's run synthesis again and see if we get a similar output. All right, so synthesis completed. Let's open synthesized design. Let's look at the schematic, and there you go. Same output, huge AND gate and no latch. So you can draw, same thing here, you can draw a huge AND gate here with 3 inputs, and this is what we intend to design. This was our goal. So let's go back to our VHDL here, and I want to point out that this is true for combinational process, but if you have a clocked logic, not a combinational, clocked logic, I'll have an example here that I can show you. If I have a clocked logic with similar logic, it will infer a storage element, but it will not infer latches. It will infer a register instead. But in this case, I explicitly say, I want a register at the output of my logic. So this is different. This is implementing a register, which is a clocked element, which is a lot easier to actually route, and it's easier to make time when you have register in your design, because it does help out with timing. But latches usually don't, and they're most often infer unintentional in FPGAs, to be specific. But guys, that's pretty much it. I hope this was informative, and we're gonna be talking about how latches are inferred for a variable later on. It's a bit different, but that's for some later time. And stay tuned. Thanks for watching, and I'll catch you later.